Okay, let's take a look at some advanced timer applications here. Before we get into this, I just wanted to review the time contacts. So we have, here's the designations here, normally open, time closed. And so the first thing that you do in order to draw these is that you are going to draw the first part here, normally open. So this is going to be drawn as a normally open. This one is going to be drawn as the first two are normally closed. This one's a normally open, and this one's a normally closed. Okay? And then the arrow indicates how it is going to end up. It is going to be time closed. Well, if this is currently shown as open, in order for it to close, the arrow says it's going to have to move up. Okay? This one's normally closed, and it's going to end up open. Well then, it's going to have to move up. Okay? And those are my on delay timers. My normally open timed opens, well, it's shown as open, and it wants to end up as open. So that must mean that it's going to close, but then would have to open again. So if it closes and then needs to open again, it would have to move down. This one's normally closed, and it's going to be timed closed. So once again, it's going to, and at some point, going to have to open, and then it would have to then close again. So these are my off delay timers. Notice the off delay timers, the arrows are down. The on delay, the arrows are up. Okay? Now, we did some sequence of operations. So what I have an example here is a sequence of operations. Now this one is in your book, all the ladder logic for this. But we're just going to take a look at the sequence of operations without ladder logic about how you think that this would really work. Okay? So if we turn the disconnect on in this ladder logic and the electrical diagrams are in your book, if we turn the disconnect on, we're not going to have anything immediately happen. Okay? If we turn the master control relay PB as pressure, we're going to get the power light to come on, and then when we release it, it's going to stay on. Okay? And we haven't done anything else here, so nothing else is going to really happen here right now. As a matter of fact, I'm just going to go ahead. I know that this power light is going to stay on the whole time until the MCR stop is pressed, and then once it gets released, it would go off again. So maybe somewhere in here between being pressed and released, it's going to go off right in here. That's the power light. And the master control relay tells me that I have power. So when I push the double operator start, that's going to start it. And you would think that the way that this works is it clamps apart. Limit switch tells me that it's been clamped. Then it turns on the drill. It's going to drill down to hits limit switch, back up, turn the drill off, release the clamp. Okay? So we're trying to get a sequence of operations here just by kind of realizing the order of operations of what this machine would do. Okay? So I hit my double operator start, and then that's going to cause us to clamp. Okay? And that's solenoid A. So I would think that I would get a solenoid A to clamp. Okay? And then when I release the buttons, it's going to stay clamped. Okay? And what that is going to do is start this solenoid A to come down, and then when it finally moves all the way down here, and it makes this limit switch right here, okay, 1LS activated, bang. What is 1LS activated going to do? Well, solenoid is going to stay on because it's still clamping, but then it's probably going to start up solenoid. It's probably going to turn the drill on. Okay, so right here I would have the drill motor come on, and then it's going to start, because it's clamped, it's going to start coming down here. Okay, so in order to come down, the forward solenoid is E. So there you go. Makes sense, right? Click, clamp, drill on, starts coming down. It then comes down until it hits 3LS. That must mean that it's went all the way and it's drilled the hole. So what happens at that? Well, we're still clamping the part. We don't want this clamp to come up. So that's the clamp. And then once it makes a limit switch, the drill is still on, but that solenoid F comes on. So that's the retract. So drill's still on, it goes down, and it starts coming back up. It then comes back until it hits the 4LS here. Well, there we can turn off the drill motor. We can turn off the retract, right? But then at that point, we're done drilling. We can probably let go of the part. And that's solenoid B right here. That's the unclamp. So then it starts unclamping. And then when 5LS is activated, that just kind of just means that this thing's done. So something else would happen. And then MCR pressed, we said that kill the power and disconnect off. So there's kind of an order of operations, just trying to think logically about, you know, how this thing would work right here without ladder logic. But that ladder logic is at the end of your notebook, and you can take a look at it, and it's a little bit more detailed than that, okay? You had a homework assignment that was this garage door operation here that opens and closes a garage door, okay? And what it does is it's got a latching and unlatching relay, and what this did is that when you push the lock out, this was a mechanical latch, so this stayed latched on. If you killed the power to the garage door, it doesn't matter. This was held in place mechanically, and because this was held in place mechanically, some of these contacts were going to be open, and that you could not open up the door from the outside here, okay? That's the way that this is supposed to work. So the way that you come through here, we did a sequence of operations. Disconnect off. I don't really see anything happening there. You hit the 1LS and 2LS. Well, there's nothing going to happen because there's no power. When you finally do turn the disconnect on, you're going to see that we're going to get power down here, and then some of these can be directly powered versus a limit switch. And assuming that this was locked out when we started, we would have the door would be closed, the light would be on down here because the limit switch is going to be closed, and one LT locked because we assumed that the CRL had been pushed, you know, the day before and that we had locked it out. And then the one CRL here, now what about that? I'm going to put a little square around this because it's not energized because we haven't pushed the button, but it's held on. So that means that these contacts here, the CRL contacts, has switched states, but it's really not energized, okay? So 4PB, we press that. So 4PB is, we want to open this up from the inside. So what happens is the door is still closed. We're just starting to open it. It hasn't left the limit switch yet. The forward coil starts opening the door, and what that did is it did cause because this was closed here, because this was closed, because it was mechanically held, it does trigger the unlatch to occur while we press it, okay? So now the door is coming up. This is deactivated, so that light goes off. The forward coil, you know, is still staying on, so there you go. And it's going to go all the way up until it hits the 1LS. And so when it hits the 1LS, well, it's going to signal that the door is open here. We get the door open light. And that's going to turn off the forward starter here because I got the LS here. So obviously when it gets to the top, it's going to turn off. Okay. Now we go and we hit 1PB. We press and released. So the 1PB is the lockout. So what we're doing, I guess, is we're locking this out at the top. So what happens? Well, the door is still open, so we get the light on. We're going to get the lockout light to come on, right? And then we're going to get the CRL to come on, okay? We release it. I'm going to put the square around here again. And what I'm saying there is we're not energizing the coil, but it's mechanically held on, so the contacts with CRL are mechanically held on. Just be aware of that. The door is still open. Okay. I then go and I'm going to 5PB pressed and released. So 5PB is an inside close. Well, you can close this from the inside, you know, when it's locked out, but you can't, you know, we're trying to open it from the outside, it wouldn't work, all right? But when we push the 5PB and pressed, well, that takes the CRL unlatch. It does unlatch it, so that would disengage, the mechanical, and it would start the reverse coil. We're going to start closing it, and the door is still open, but once it walks off that limit switch right there, it's not. But so it's going to keep closing. During this time, it says 2PB press and release. Well, 2PB is we want to hit the stop button. So we hit the stop button, everything stops. The only thing that was on was the reverse coil, so that stops. Everything stops. I got nothing there. 7PB is pressed. 7PB, we're going to continue on with the close. And since we're not locked out, it's going to continue to close. So if I got my 7PB, we're back to the reverse. It's closing. And then it goes all the way until it hits 2LS. And the 2LS means that it's closed. So once it closed, we get the door close light to come on, and it kills the coil. Okay? Now I've got 6PB pressed and released. 6PB is the open again from the outside, which we can do because we're not locked out. So it's still closed, but then back to opening it again. So the forward starter goes after it walks off, after it starts moving up and walks off the limit switch. It just keeps running like this. 5PB is pressed and released. 5PB is the close button, but this has mechanical interlocks in it. So when one starter's running, the other one can't be running. So it's not really going to do anything if you try and push this right here. It's interlocked. It's electrically interlocked. It's just going to keep going. And so finally, when it gets all the way up, it's going to be that the door is open right there. Okay? And it would stop again. It would turn off. And at this point, if we kill the disconnect, everything would go off. So I think I have all that, Aaron. You can take your homework and compare it to your homework and see how it turned out, okay? And understand it and see how it's going. Now, we have some advanced timers here that I wanted to go over to be sure that we understood the timers. And so the first one here is we're going to have a momentary start push button is going to turn on a red light. And that means that a motor is about to start. Boom, you push the button, the red light comes on. There, could be a horn or a light. 30 seconds later, bang, the motor starts. So that red light's kind of like our warning, okay? And so what we're going to need, because it's a momentary push button, we're going to need memory. So when I do this, I'm going to go ahead and I'm going to start with 1PB, and I want to turn on, I want to get some memory here, okay? Some instantaneous memory. But because I've got some timing going on here, instead of using a control relay, I'm going to use a time relay, okay? And this is an on-delay time relay, and it's going to be set for 30 seconds, okay? And so this works just like a normal relay with my instantaneous contacts. I'm not using the time contacts yet. I'm just using the instantaneous contacts. So I hit the PB, these close, and I've got memory, okay? So I'm all set there. So now what is this going to do? This time relay has to turn on, a light, okay? So what will that look like? Well, I guess I'm going to cheat a little bit right here. That I could say there's going to be some contacts right here turning on a red light, okay? And then the red light is going to, the PB causes a red light to go on, indicating that a motor is about to start. Okay. So what I could do right here is I could have some closed contacts right here, and that these would be timed open. Okay? TR. Timed open. So I hit this. The time relay holds itself on with instantaneous contacts. 30 seconds later, this light goes off. How's that look? So my question is, what turned this light on? Well, let's use those instantaneous contacts right here to not only hold the memory here, but when I hit the push button, I get the red light on. 30 seconds later, this time's open and the red light is off. Okay? There we go. Now, 30 seconds later, the light's off, but the motor has got to come on. So what I'm going to do is I'm going to put some contacts here, and at this point the motor starter is going to come on and the green light. Let me just put that in parallel. So when the motor starter is on, the green light's on. That's off, these are on. So what is that going to be? Well, I'm going to have something that's open because they don't come on until 30 seconds later. So I'm going to go open, timed, closed. Okay? So one more time. Push button, time relay instantaneous. That closes, I get the red light. But this is timing. 30 seconds later, this opens, this closes. Therefore, this goes off, these go on. There's a motor starting with an on delay timer. Let's take a look at another one. Garage door with an off delay. We just did a garage door. This one I'm going to simplify it quite a bit. So I got a momentary PB causes the garage door to open. Okay? And then the garage door is going to go up, and then a limit switch is going to stop it from opening. Okay? So let's just go ahead and try and take a shot at that. We have a momentary 1 PB. Okay? It's going to go, and I'm going to have a limit switch here that's closed. That's when the door opens all the way. It hits that. And I'm going to turn on my motor starter. Okay? Let's give it a little memory. 1 PB hits the motor starter. The door starts moving up. Bang. Hits the limit switch. And it goes off. So we've opened the door. Okay? It says a light comes on. So we've got to turn on a light. Okay? So apparently, we're going to need, and it's going to come off after 3 minutes. So what we're going to do is we're going to use a motor starter right here. So not only does it turn itself on with memory, it's going to turn on a timed relay. And I'm going to use an off delay this time, set for 3 minutes. Okay? So, what is this going to do? We say that we want to have that turn on a light. Okay? So when this comes on, we're going to have some contacts right here that turn on the light. Okay. So what are they going to be? They're going to, we need these to be open, but then we need them to close, and then 3 minutes later we need them to open again. Okay? So we need these to open 3 minutes after the door is open. So let's try this and see how that works. I hit the PB, the motor starter gives itself memory. And the motor starter turns on the timed relay. These contacts close. Nothing's timing yet. We actually have to turn this off right here for this to start timing. So at this point, we've got the motor starter on, and the light is on, and the time relay on. These are all on. The garage door opens, limit switch opens. That means that this motor starter goes off, and that this opens up, which means this then starts timing. 3 minutes later, it opens up and the light goes off. So your light stays on as soon as you hit the motor starter, and then it goes off 3 minutes after the garage door is open. Okay? Let's do a time cylinder with on delay. PB activates a latching relay. So here I'm showing the holding circuit, but this one we're going to use a latching unlatching relay just to get a little practice with that. So momentary PB right here is going to do a CRL, latching relay. So I momentarily hit that. This is mechanically held on. And it says that we need to extend a cylinder. Okay? So I'm going to have some contacts here, these CRLs. Just turn on the solenoid here, right? And that's on the first cylinder. So when I hit the push button, the solenoid is activated, and the cylinder extends, and it's going to go out. And as the cylinder goes out, it then goes out and it runs into a limit switch, okay? So when it runs into this limit switch that's normally open, it runs in that limit switch, it closes, okay? It's extended, that limit switch tells us that it's closed. And so what are we going to have that limit switch do? We're going to have that start a time relay, and it's going to be an on delay, and it's going to be 5 seconds. Once again, PB latches on this. The solenoid, because this is latched on, extends, hits the limit switch, and then the timer starts timing. 1, 2, 3, 4, 5. What do we want that timer to do? It says it's going to unlatch the relay. So, if I come here, I'm going to need some contacts here. And I'm going to have an unlatch here. Okay? So, what do I want here? Well, I don't want it to unlatch yet. I want it to unlatch after 5 seconds. So I want it to be open. Then I want it to close after 5 seconds. That's my 5 seconds to close. Okay? Push button latches it on. This becomes closed. I've got my cylinder on. It pushes out, and it pushes on the limit switch. Starts the time relay. 1, 2, 3, 4, 5. This closes, and it unlatches. Because this unlatches, well, guess what? That opens, because it's no longer latched. That goes off. The cylinder retracts, and the cylinder then comes off of this limit switch that it had closed, right? So then that's reset. And then this is reset, it opens back up, and everything's back to the way it was. And it can just run this over again, hit the push button, it would run again, and until it unlatched 5 seconds later. Then it would be all reset. It could go again and again and again. That's using a cylinder and a limit switch with an on delay. Let's move on to a couple more advanced ones here. Okay, I've got a blinking light here. And the reason I'm going to do a blinking light is I'm going to show you 2 different ways to do this blinking light. Okay, we have a momentary latches on the circuit, and 2PB unlatches the circuit. So instead of using the latching and unlatching, I'm just going to draw it, I guess, just like normal memory, if that's okay. So right here, I'm going to have 2PB, that's my normally closed. And then I'm going to go here with 1PB, that's my open. And then here's my 1CR. So if I hit the start, I want memory here. There's my holding circuit. Start, stop, memory circuit. We've done that over and over and over again. So now what we have, we want to blink a light. We're going to blink a light 4 seconds on, 2 seconds off. 4 on, 2 off, 4 on. It's going to keep blinking. So I think we have to turn on a light right here. Okay? So this 1CR is going to turn on a light over here. But I know that we're going to have to turn this light off eventually, so I'm going to put some contacts here. I don't know what. But I'm going to put a closed switch here, okay? So that when this CR comes on, this light comes on. Okay? And then this CR also is going to turn on a timed relay. So over here, I'm going to put a 1TR. I'm going to put some more contacts here. I know that I'm going to have to open these up eventually. I don't know with what though. Okay? This is a non-delay. 4 seconds. Let's just review. Start. I got memory. So I got this control relay. It is on. It's not going off unless I hit stop. Control relay. I've turned on a light. And I've turned on the relay for 4 seconds. So what do you think I want to do with this 4-second relay? I got the light on. 1, 2, 3, 4. Let's time this contact open for my 1TR. Okay? That means this light goes off after 4 seconds. This is still on, but that light went off after 4 seconds. Well, okay, light on, 4 seconds later, light off. Now, the light has to stay off for 2 seconds. So we're going to need another timer here, I can tell you right now. something here has to start another timer. And I'm going to use an on delay for 2 seconds. I don't really want this running yet, so I'm thinking that this is going to be an open switch. Okay. What is going to start the second timer that's going to turn the light back on? Well, it's going to be the first timer. Okay, so I'm going to put the first timer right here. I'm going to close this with the first timer after 4 seconds. So here's what we got. Memory, got the control relay on. The control relay turned on the light and the timer. So the light's on. 1, 2, 3, 4. This opens, the light's off. So light on, 4 seconds later, light off. This time relay not only turned the light off, it turned on the second timer. So light went off, timer went on. 1, 2. What am I going to do with this? I'm going to have this timer open up this contact. 2TR. Okay, so when that opens up, this kills the timer, and that time contact was what turned the light off, so the light will turn back on. So and when this timer opens up and goes low, well then this opens back up. So I get a little cascading here. Let's look at it one more time. Control relay on. My light's on. My timer's on. Light's on, timer's on. 1, 2, 3, 4, open. Light off. And close this. 1, 2. Reset the timer. The timer's what turned the light off. So the light comes back on. 1, 2, 3, 4. Close this timer. Oh, turn it off. 1, 2. Open this timer up. Light's back on. 1, 2, 3, 4. Open the timer. Start the next timer. 1, 2. Open this one. Turn the light back on. So one of these timers, the 4-second one, turns the light off. The second timer resets the first timer. This is my blink timer. This was my reset timer. This blinks for 4. This resets for 2. Blink 4, reset 2. Blink 4, reset 2. Study it. This is called cascading timers right here. One timer starting the next is called a cascading timer. Let me show you one other one here. And I'm going to start with the same circuit that I had right here. Okay? I'm going to have the stop, go into the start, go into the control relay, giving me memory. Okay? This was my 2 PB. This is my 1 PB. So there's my holding circuit. Okay, I'm going to have the next line exactly the same. I have 1 CR. I'm going to have the closed turning on the light. Okay, and this is my 1 TR. Same thing. Okay. Now this gets a little bit different. Well, maybe I'm going to have my 1 CR right here. And I'm going to have my same thing right here. 2 timer. And this is my 1 timer. This is an on delay. 4 seconds. So everything is exactly the same so far. I get memory. I turn on the light and the timer. Because this shut. These all shut. 1, 2, 3, they all shut. So the light and the timer come on. 1, 2, 3, 4, the light goes off. Okay? We got to turn the light back on. Before we had a cascading timer. This is where it becomes a little bit different. We're going to use the same 1 CR and we're going to turn on 2 TR. It's an on delay. And instead of doing it like we did over there, I'm going to make this 6 seconds. Okay? And so after 6 seconds, what this 2 TR does is it opens the 1 TR run and it opens its own rung. So when these rungs both get open, then these just go back to the way they were, and the light comes back on. And then 1, 2, 3, 4 opens up, 5, 6, then these open up and they go back to the way they are. So this one is called cascading because 4 started to 2. Well, 4 plus 2 is equal to 6 seconds. Whereas this one is in parallel. The control relay just started the 4-second timer, and then it started the 6-second timer at the same time. So that this one had opened up after 4 seconds, and then this just kept running at the same time, and then 2 seconds later, these two opened up, resetting themselves, and then the light went back on. So we got 6 seconds here with 2 in parallel, or we got 6 seconds here with one timer starting the next timer, either one. Okay. So for your lab, what you're going to do is you are going to take a shot at drawing up both of these motor starting circuits here. Okay. The lab says do one. On a separate piece of paper, I would like you to draw them up both. Okay. And I'm interested in the ladder logic side of it. Okay. And I also want you to draw the power side of it for this motor. And that will be what the lab will be, is to attempt to draw motor start 1 and motor start 2. And that's what you will turn into your lab. And so take a look at these timing examples I got. This one's a little bit easier. And then this one is related to this one here, okay, of cascading or parallels. You got a couple of options there. So that's what the lab will be for this week.